Address resolution protocol. This is not going to be far from what we did in our last class. So you're going to see some demonstration. And the reason why I'm doing some of this is I'm taking my time to build this foundation. There's some basic things, small things at the foundational level that people don't really understand or they don't take note of. So I'm taking my time to address all of these things. So if we're able to finish this on time and we're good to go with this, we can move to another concept. And let's see how far we can go. Please, if you can see my screen, let me know. Thumbs up. You can see my screen. You can hear my voice. If there's any challenge, you can just write on the WhatsApp group for me, class rep. Okay, thank you. Thank you, guys. Thank you. All right, so here we are again, still talking about layer 2 and layer 3 addresses. MAC address and IP address. Layer 2, layer 3. We are here again to talk about them into this class. Oh, what's my pointer not working? Just a minute, guys. Okay, so don't forget in our last class, I talked to you guys about MAC address, which is a layer 2 address, which is a physical address. And I also mentioned briefly about IP address. MAC address is inbuilt into the network card of your computer. IP address, you are the one to assign IP address into computer. The whole of next week, all things being equal, this is what we're going to be dealing with. We're going to be dealing with IP addresses the whole of next week. So I'm hoping to finish to reach my target today into this class so that we can move to something else next week. So what we want to talk about today, class? We've talked about layer 2, layer 3 of the OSI model, data link layer, network layer, and we have confirmed that at layer 2, source MAC address and destination MAC address is added. At layer 3, source IP address and destination MAC address is added before the message can move to the destination. That is just the normal thing. So I don't want to waste time on this slide here. That is just the normal thing. So I want to take this into another level today. I don't just want to explain to you on with the PowerPoint. I want to demonstrate some things to you personally. And this app is going to be in two portions or two parts. I will do address resolution protocol now. Then when we are done dealing with router configuration, I will do another one. I will do another address resolution protocol. I've decided to split it into two. This is going to be like the part 1. So what am I trying to communicate here? If there are two computers that want to talk to themselves, let's put a switch in between. There are two computers that need to talk. Before this computer can send the message to this other computer, let's say computer A, then computer B. Before computer A can send the message to computer B, at layer 2, we know that source MAC address, which is the MAC address of this computer A, and destination MAC address. Oh, sorry guys. So which is the MAC address of the computer B must be added. Source MAC address, destination MAC address must be added. You know, guys, you know that before. Then at layer 3, source IP address, which is the IP address of this computer A, and destination IP address will be added to the message. I'm going somewhere. Apart from these things we've discussed in our last class, computer A, we have a table called ARP table. ARP, address resolution protocol table. Address resolution protocol table. Computer B also will have its own. In essence, all the computers on the network will have their address resolution protocol table. So what is going to be in that address resolution protocol table? MAC address of computer B, map to the IP address of computer A. Meaning what? Before computer A can send message to computer B, it must know about computer's B IP address and must also know computer's B's MAC address and map them together in the ARP table. It's like putting them side by side, and I'm going to show you guys. So it means I cannot send the message to you until I know your IP address and your MAC address, or until I have your IP address and your MAC address in my address resolution protocol table. So what if I don't have your MAC address? Because definitely what we want to do in today's class, I will definitely know the IP address. This is what I'm trying to say, guys. Back to the same topology we used in our last class. This is Roland here. Roland wants to send a message to class rep. Roland must have class rep's IP address map to MAC address. That is for class rep's IP address and MAC address. He must have these details in his address resolution protocol table. That's the way computer function. So why on earth won't I have your MAC address or your IP address? It's possible. There are situations whereby Roland knows the IP address of class rep. He does not know class rep's MAC address. So what will happen at that point in time? Remember in our last class, I said I'm going to explain the reason for two envelopes. So anytime a computer wants to talk to another computer, if one of these addresses is missing, this computer doesn't know about that address, especially in this context right now, MAC address. Roland is going to send an ARP request. An ARP request is a broadcast. It simply means, hello everybody, I am trying to talk to the owner of this IP address. If you are the owner, could you please send me your MAC address? When Roland sends the broadcast, the message goes to the switch. The switch sees the destination MAC address and knows that that message is meant for everybody. It sends to class rep, it sends to Faustin, it sends to Uchi, and because the message does not belong to Uchi and Faustin, they will discard it, read the destination, read the message and say, no, I'm not the owner of this IP address. Then class rep will respond. By the time class rep responds to that message, it goes through the switch back to Roland. Then Roland now put that details in his ARP table. That is when Roland can now send the real message to the class rep. So there will always be ARP requests on the network. Why? I need to know your IP address. I need to know your MAC address, and I need to map the two of them together in my ARP table. If for any reason one is missing, especially MAC address, I send ARP request. What if it is your IP address that is missing, which is very difficult? I'll send what you call RAP request. RAP, reverse address resolution protocol. RAP, reverse address resolution protocol. So the point we are making it, we're just trying to understand the way computers communicate, what goes on behind the scene. And I'm going to show you guys this one today in today's class again. In our last class, I was trying to major on the switch, show you how the switch make decision, if it does not know about where you are located and all of that. This is another concept again. And everything must be in place. So summary, what I'm trying to say here. Every computer on the network will have their ARP table. And in the ARP table, there is a combination of people's MAC addresses and their IP addresses, people's IP addresses and their MAC addresses. If for any reason I don't know your MAC address and I need to talk to you and I have your IP address, I'm going to send a broadcast. Let's check it. Let's check this out. Let's go to the first computer here, which is Roland's computer. I will click that icon, go to command prompt, and just type ARP-A. What I'm simply telling Roland computer is, I want to see your ARP table. Show me what you got in your ARP table. I will hit enter. You can see in this scenario now, in this place now, this computer is telling me, I don't know, I don't have anybody's entry. I don't know about anybody. Meaning what? I don't have anybody's MAC address mapped to their IP address in my entry. So this table is empty now. So if Roland needs to now talk to class rep, And we can simulate that conversation with a ping. I'm going to come and talk about ping in today's class again. If Roland needs to talk to class rep, Roland is going to try to reach the IP address, but because there is no MAC address in the ARP table, there is no way Roland is going to put the destination MAC address on the message. So if we try to ping, Roland knows his own IP address, source MAC address. When we say ping, we are trying to go to a particular destination. That's the destination IP address. Roland knows his own MAC address, which is, let me show you guys. Let's go to this command prompt again. Say IP config /all. IP config /all. If I hit enter right now, let me maximize this. I need you guys to say something. IP config /all. I've talked about this command before. This is Roland's IP address. That will be source IP address. It will be added to this message. Source IP address. This is Roland's MAC address. It will be added. But if I want to go to class rep is .2. I gave her .2. 192. Let's check that one first. Class rep is here. IP config /all. So say class rep here. She has 192.168.1.2. Don't worry about IP addressing. That's what we're going to be dealing with throughout next week. We're going to go out to IP addressing. So don't bother about that. So look at this now. Look at this now. So let me write out class rep MAC address because I need to show you something. Okay, so now this is class rep's IP address. This is class rep's MAC address, and Roland want to talk to class rep. So for us to simulate that conversation, I'll go to my computer here and say ping. I will ping 192.168.1.2. I want to talk to class rep. So this my computer knows it's trying to talk to a particular IP. That will be the destination IP address. So, but in the ARP table here, this my computer does not have MAC address of class rep. And as a result of that, it's going to send ARP request. It's going to broadcast. It's going to send a broadcast. Let's check it out. Let's go to simulation mode. And then I'll hit that enter to talk to class rep. So now I've hit enter. Now you see that there are two envelopes. That's what I talked about in our last class that I will demystify today. If I click this envelope here, the first one precisely, I need you to see something here. See something here, guys. At layer 2, this is Roland's MAC address, which is the source MAC address. The message is going to FFFFFF in 12 places. And what did we say about FFF in 12 places? That is a broadcast MAC address, meaning this message is for everybody. Which protocol are we dealing with, guys? Look at it here. Address resolution protocol. That's the protocol. So what's the big deal? This is my source IP address. This is the person I'm trying to talk to. And because I send what is called ARP request, which is a broadcast, I am simply saying, hello, everybody on the network. I am trying to talk to 192.168.1.2. If you are 192.168.1.2, could you please send me your MAC address? I cannot complete this package or this frame. I have added source MAC address. I need to add destination MAC address, and I don't know the destination MAC address. So what am I doing? I am sending a broadcast, and that broadcast is called ARP request, address resolution protocol request. Address resolution protocol request, and it's going to go to everybody. And let's see how the switch is going to handle this message. So the message will go to the switch. If I open the envelope, you're going to see the way the switch is going to deal with the message. The switch look at the message and say, where is he going to? He's going to FFFL. Nobody has this particular MAC address. This is everybody. is coming in from a particular, this port number, this port is going to FFFF. So how will the switch deal with this? The switch is going to forward the message out of port 1. There's somebody on port 1. Out of port 2. There's somebody on port 2. Out of port 4. There's somebody on port 4. Take note of one thing here. When the switch is broadcasting something it has gotten, it will not send it out to that particular port where you got the message from. I am on port 3. I am the one sending the ARP request. The switch does not have, it will not make sense for the switch to send that message back into that place. So the switch will replicate that message, send it out on port 1, send it out on port 3 and port 2, and then also send it out on port 4. Why? Because somebody needs to respond to that message. Whoever is the owner of this IP address needs to respond to that message. The switch doesn't know too. So because the switch has already destination MAC address, it needs to broadcast this message. I think I should have taught you guys this before I went to the internet switching. I was trying to follow that chapter. Okay, so let's see how the switch will now deal with this message. So if I click next again, you see that the switch replicated the message, send a copy to class rep, a copy to Faustin, a copy to Uche, and they are not the one to respond back. Let's see what the class rep is going to respond with. If I open this envelope right now, you will see that the class rep is saying, oh, I can see I am the owner of that message. I am the owner of that message. How did we know that one? The class rep is responding. Look at the message here. Because when you are responding, your source MAC address will be added to the message. And destination MAC address is where the message is going to. You know, the message came from this MAC address before, C6, D7. That's the source MAC address. By the time the other side is replying, the source MAC address becomes the destination, and the person that is replying now becomes the source MAC address. So what the class rep is simply doing right now, I am the owner of this 192.168.1.2. It's replying back to me here. And that is when my computer can now put that message in its ARP table. So the message is sent as a broadcast. The real owner of that IP address responded with the MAC address. And we can see from this breakdown of the packet here. So the class rep is responding back to me. So when she's responding, her MAC address becomes the source MAC address. My MAC address becomes the destination MAC address. And then the message goes to the switch. And then the switch now sends to Roland. And if I stop there, you see that this Roland has now built his ARP table. But because it is a ping packet, ping, we're going to talk about ping in today's class again. Ping, which is based on ICMP, to test for connectivity. The real message now has to go to the destination, which is this next envelope right now. We're trying to test for connectivity, but that job couldn't be done because my computer does not know about the MAC address of class rep. So there's a need for broadcast, and this thing happened very fast. Now that my computer knows that, it has that details, then the ping can now go to the destination. So if I open that envelope right now, you will see that the protocol we're going to have there is different. The message is going to the destination now. Okay, Roland now knows the source MAC address, sorry, the destination MAC address of the class stream. Now watch what is going to happen. It's supposed to show me the protocol. Maybe it's when it gets to the switch. Okay, no, this will be at layer 3, yes. So it goes to the switch, and then it goes to the class rep, and class rep respond back, and then it goes to me, and that will be the end of that conversation. You're going to see that means Roland can talk to class rep. So this is my point. If we now go to that ARP table right now, we are going to see something there. Let's check the ARP table again. Let's see what Roland has done. Now Roland has gotten class rep's IP address and class rep's MAC address mapped together in his address resolution protocol table, ARP table. So if there's any other conversation with class rep right now, that conversation will go smoothly. There will be no need to send any broadcast again. So as it is right now, Roland can talk to class rep. There will be no need to send broadcast. But if Roland wants to talk to Fasting, or Roland want to talk to Uchi, because Uchi is not in my ARP table, Fasting is not in my ARP table, I have to repeat the same thing again. Forget about the switch now. We've taken care of switch in our last class. Or even Uche, if Uche want to talk to fasting, if she does not have fasting's MAC address in the address relational protocol table, she's going to have to broadcast to first of all get that details before that conversation can take place. And this is what happens behind the scene on the network. Let's get another example, guys. Let's say I want to talk to Uchi. Let's check Uchi's IP address. IP config. Uchi is 192.168.1.3. What about his MAC address? Look at Uchi's MAC address here. He ended with 2762. Okay. Check Roland's MAC app table. Uchi is not here. Uchi is not in my app table. So if I need to talk to Uchi right now, the same thing that I did for the class rep, I have to do it for Uchi. I need to first of all find a way to get his MAC address into my app table and map them together. Because that MAC address needs to be in the destination MAC address. It needs to be on the frame. Source MAC address, destination MAC address. It has to be on the frame. Same thing will be repeated. Let's give it a try. So I go to Roland. Let's try to talk to Uche. Ping 192.168.1.3. That's Uche's IP address. Now we have discovered that that MAC address is not in the app table. Enter. Now watch out. If I open the envelope again, you're going to see that there is going to be a broadcast. Same thing that happened to class trap. If I open the envelope, you see a broadcast. This is me here. I'm sending the broadcast to everybody. This is the protocol. This is my IP address. This is the person I'm trying to talk to. I am simply saying, based on this protocol, all I'm looking for is MAC address of the owner of this IP address, because I don't have that in my app table. And as long as I don't have that in my app table, I cannot communicate with the person. So if I play this now, you see that that goes to the switch. The switch replicates and sends to everybody. Then Uche will be the only one that will respond. The other discarded it. Uche responded back. If you click that envelope now, you see that Uche's MAC address will be the source MAC address. You see, this is Uche here. You say, oh, this is me responding to this MAC destination MAC address, and this is Uche's IP address. That is the source IP address now. Uche is now the source because he's the one, is the sender now, he's the one replying. Then this going to Roland. So you see, thank you. Then it goes to the switch. That is after this, the real information can now take place, which is the ping. That is the test for connectivity to see if they can reach themselves, and then the two computers they will successfully have communicated. So if I now go to real-time mode now and go back to Roland and check the app table of Roland, you will now see that Uche's MAC address is in that app table. Look at Uche here. Map to his Uche's IP address, map to his MAC address. Roland has taken note of that. Subsequent conversation, there will be no broadcast between Roland and Uche. If we repeat this again, you see that there will be no broadcast. Now, I'm not talking about switch now. I'm talking about computer itself dealing with MAC address and IP address. If I hit that enter again, because this computer already knows where the where Uche is by MAC address, or let me say it has Uche's MAC address and IP address. If you just send one envelope, it goes to the switch. The switch doesn't know. The switch does not need to replicate it. It's sent to Uche. At what point will the switch have to replicate this? That's what we discussed in our last class. If for any reason the switch doesn't know where Uche is located, then the switch will replicate it and send to everybody. At this point in time, the reason why, let me go back to return. The reason why the switch will not replicate this now, if we go to the switch MAC address table, you will see that the switch has taken note of that. Because during the process of HAP, Roland sent a message, Uche replied, then the switch knows that Uche is located on so port. Let's check it. Show MAC address table. Look at Roland here on port 3. Look at Uche here on port 4. The switch has built the MAC address table even during that app. Even if the switch doesn't know where you are, because you have to respond to the app. So the switch also will take advantage of that to add it to the MAC address table. But if I clear this table right now, the switch will replicate. Even though Roland knows what is this called? MAC address and the IP address of Uche. Roland will not send a broadcast, but the switch will broadcast because the switch does not know where Uche is located. So take note of that. So this is hinder themselves. So you need to know when one is separated from the other. So it means if Roland already have those details, which has responded, that means the switch also has built his MAC address table. So therefore means when the message gets to the switch next time, the switch won't broadcast. It will just send to Uche directly. Why? Because he knows where Uche is located. So they will enter themselves. They're interconnected. So computer, every time we broadcast, if it does not have one of those details, both the IP address and the MAC address must be available, must be present in the ARP table. And the switch also will broadcast if it does not know where you are located. Even if it knows where you are located, what if the table has cleared up? I talked about the timer. The table has a timer. That's the MAC address table now. It has a timer. If it has cleared up, it will broadcast everything because it doesn't know where you are. It has to learn everything again. These are concepts I want to communicate to you guys. Address resolution protocol happens every time on the network, and this is based on IP version 4. Guys, IP version 4. This discussion is not based on IP version 6. IP version 6 has a way of also sending, we said there is no broadcast in IP version 6. I have a different video or different chapter on IP version 6. I think it's in it too. You cannot learn everything about IP version 6 now, but just understand this one now. It's the same concept when we come to IP version 6. You will always have ARP requests on the network. Put it another way, there will always be broadcasts on the network. And that is why when you come to a level, that should be next week, hopefully, we'll teach you about segmentation. Don't build a network that is too big, because broadcast, that network can be caught up in a broadcast storm and everybody is hooked. Because what you guys need to understand is the same bandwidth we are using to process data is the same bandwidth that these things are using to process broadcasts. So if everybody is sending broadcasts on the network, I am looking for Uche's MAC address. I'm looking for Class's MAC address. I'm looking for, and the broadcast is too much. The network will be caught in what is called a broadcast storm. And guess what? That network will just be freezing, or it's now slow. People will now be calling you as a network engineer. We don't know why the network is slow. The network is not fast. Not because you don't have enough bandwidth, but that bandwidth is being consumed by broadcast. That's why we do segmentation. And we're going to come to that in another class. There will always be broadcast, but you must learn how to manage the broadcast. Put the broadcast where it belongs to and let it do its job on the network. So this is a summary of what I want to teach you guys on address resolution protocol. I'm going to give the room for question now before we move to another part.